Gibson here. Today we're going to move on with lesson 5 on our unit on linear and quadratic functions. And today we're going to look at how do we find the minimum or maximum value of a quadratic function. So the objectives are, first, how can we graph quadratic functions using properties of parabolas? Those properties include the axis of symmetry, the vertex, and the y-intercept. And then how can we use those properties to determine whether we have a minimum or maximum value for a quadratic function, and what would that value be? So let's look at how do we graph using properties of parabolas. So in this big blue box here is the critical information you'll want to get in your notes. Now we're going to use the standard form of a quadratic function, ax squared plus bx plus c. Notice it says a cannot be equal to 0. If that were true, then we wouldn't have a x squared term. It would no longer be a quadratic function. It's okay if we don't have a bx or c term, the linear or constant term. As long as we have an x squared term, it's still a quadratic function. So first off, how do we know whether the parabola opens up or down? We're going to look at the a value. So the a does the same thing as it did in the vertex form, right? When we looked at transformations. If a is positive, then it opens up, or there is no reflection. If a is negative, in other words, less than 0, then we have a reflection. The parabola opens downwards. Okay. All right. Axis of symmetry. That's an important feature for us to plot if we're going to be able to sketch the graph. That's the vertical line that divides the parabola into 2 equal halves. So we have a formula for that. We find the x value by taking the negative of b divided by 2a. B is our linear coefficient. A is the quadratic coefficient. To find the coordinates of the vertex, well, we already have the x value. Right? How do we find the y value? We're going to do that by substituting x for y into our function and solve for y. Once we do that, we will have the coordinates of the vertex. So we have the axis of symmetry, the coordinates of the vertex, and then the last thing is the y-intercept. So remember, this is where the parabola will cross the y-axis. That occurs when x is 0. So if we put 0 in for x, the first 2 terms go away. All we're left with is the c, or constant term. So very easy to find the y-intercept. All right, let's look at an example where we put this together. So we have a function that we want to graph. Our equation is x squared minus 2x minus 3. So first, does it open up or down? Well, what's our a value here? A value is a positive 1. Now, I didn't put that in front of x squared, but if there's no coefficient, we can assume it's a positive 1. So if it's positive, it opens up. Good to know as we begin to graph this. Now let's find the axis of symmetry. So here's where we're going to use that formula, minus b over 2a. We're going to put in negative 2 for b, positive 1 for a, and be careful with the negatives, right? We have a negative divided by a negative, so it's going to be positive. 2 divided by 2 is 1, so we get positive 1. So what does that look like on our graph? It means we have a vertical line that goes through x equals 1. There's our axis of symmetry. Now let's find the vertex. So we're going to put 1 in for x into the function and solve for y. So let's do that. Everywhere we have an x, we'll put in 1. And then we're going to just simplify. So we get 1 minus 2 minus 3. That gives us a negative 4. So the coordinates for the vertex are 1, negative 4. So we can put that on our graph. Down below there, you'll see the vertex now at 1, negative 4. All right, before we sketch the graph, we know it opens up, but how wide or narrow will it be? Well, the y-intercept is helpful. So we're going to put in 0, which just leaves us with the c value. So in this case, negative 3. So we know we have another point at negative 3 on the y-axis. And if we have a point on the left side of the axis of symmetry, we have a corresponding point on the right side. So now we have everything we need to sketch the parabola in. Okay, start at the vertex and then go through the intercept and its corresponding point. Okay, so that's what it means to graph the quadratic function using the properties of the graph. The properties are the axis of symmetry, the vertex, and the y y-intercept. All right, let's just do a couple concept questions here, see if you're picking this up. Does this parabola open up or down? Well, notice we have a +3 for our a value. If it's positive, it opens up. Okay, let's try another one. Up or down? Well, we have a negative now in front of our quadratic term, which means our a value is negative. Therefore, it's going to open down. All right, let's get some practice at finding the axis of symmetry and the vertex. Okay, so we're just going to do those first two steps. We're not going to go all the way through to graphing yet. We'll do that in another couple slides. So good first step is identify, right, the A, B, and C values. So A is 3, B is -6, C is -7. So let's find the axis of symmetry. We're going to plug it into that formula. We'll put in -6 for B, +3 for A. So we'd have a -6 divided by -6. That gives us a +1. So we know our axis of symmetry. Now let's find the vertex. So we're going to take that 1 and substitute it in for x, and then simplify it. So we'd have 3 times 1 squared. That's 3 minus 6 times 1 is 6 minus 7. All that will give us a -10. So our vertex is going to be at the location of 1, -10. Okay, so all we've done so far is just found the axis of symmetry and the coordinates of the vertex. I'll let you try one more here. Okay, let's do it together. So here are our A, B, and C values, 1, 2, 3. Axis of symmetry, we plug it into our formula, minus B over 2A. 2 for B, 1 for A, and we get a -1. So axis of symmetry at -1. And now we plug that in and solve for y. So -1 squared plus 2 times -1 plus 3. 1 minus 2 plus 3 equals +2. So our vertex coordinates are -1 and +2 for y. All right. Let's try graphing all the way through now. Okay, so we've got y equals -x squared minus 4x plus 1. First question, does it open up or down? Well, coefficient of the x squared term is a -1, so it's going to open down. Let's find and graph the axis of symmetry. So we start with our formula. We're going to plug in -4 and -1. So we get a -2. That's our axis of symmetry. Let's draw that in on our graph. So there's our vertical line going through x equals -2. Now let's find the y coordinate of the vertex. So we're going to plug in -2 everywhere we have an x and then simplify. Now be a little careful here with the negatives and the squaring and the parentheses. We're going to square the -2 first, think of order of operations, and then multiply by the negative or -1 in front. So that's going to give us a -4. -4 times -2 is a +8 plus 1, that gives us 5. So that's the vertex. Let's put that on our graph way at the top there, -2, 5. Now, before we sketch it, let's find the y-intercept. So remember, all we have to do is look at our constant value c for that. And in this case, it is 1. So we can put a point here at 0, 1 on the y-axis. Let's put the corresponding point on the other side of the axis of symmetry. And now we can sketch in our parabola. All right. Okay, let's move on and talk about how do we define the minimum or maximum of a quadratic function. So it turns out it's the y coordinate of the vertex that represents either the minimum or maximum value of a quadratic function. Now, how do we know whether we're looking for a minimum or a maximum value? Well, let's take the first case. The parabola opens upward. The vertex, right, is at the bottom of that parabola. So we are going to find a minimum. It doesn't have a maximum, right, because the two branches of the parabola each side go to positive infinity in this case. But the vertex stops, the most negative point you can see here is -3. So we'd say we have a minimum at y equals -3. If the parabola opens downward, right? The vertex is at the top. That gives us a maximum value. In this case, our maximum value would be at y equals 4. Now notice, it's always the y value that we are interested in when we're asked to find the minimum or maximum of the quadratic function. All right, let's look at how we would do this from the equation, okay? It's easy when we have the graph to look at it, but what if we just have the equation? Well, basically we need to find the vertex because the y-coordinate of the vertex will give us the minimum or maximum. The first question is it a min or max? So again, look at our a value. It's a -1 in front of the x squared, which means it opens down. Since it opens down, then we have a maximum, okay? So now let's find that. So we're going to use our formula, put in 2 for b and -1 for a. That's going to simplify to a +1. And then we need to put the +1 into our equation to find the y value, just like we were doing before, okay? So there's really not much new here other than figuring out how do we know whether it's a minimum or maximum. So if we simplify that, we get 6. So our vertex is at 1, 6, but the answer that we're looking for is y equals 6 is our maximum. All right, let's try this with a couple simple concepts. I'm going to give you the graph. Does it have a minimum or maximum, and what is its value? Okay, so it opens up. So we know we're going to have a minimum, and the minimum in this case is at y equals -2. Okay, very simple when we have the graph of the parabola. Let's do it again now, but I'm just asking you, does it have a minimum or maximum? And I'm just giving you the equation, not the graph. So notice we have a -2 for a, which means it's going to open down. Therefore, we have a maximum. All right, let's take it all the way through here now. I'm going to give you the equation and have you find the minimum or maximum of it. So first, does it open up or down? Well, 3x squared, that +3 tells us it opens up. Therefore, we're going to be finding a minimum. The vertex will be at the bottom of the parabola. Now let's find the vertex. So we've done this many times now. -b/2a, we put in our values for b and a. We simplify, we get a -2. Let's put -2 in for x. So we're going to get 12, +12, -24, and a +8, which gives us a -4. So our vertex is at -2, -4. So the minimum, remember, is the y value. The minimum then would be y equals -4. All right, let's look at one example here of kind of applying this to a real world situation. We have a model rocket, and we're given a function that gives us the height in meters, or sometimes we call that the altitude, as a function of time in seconds. So notice we don't have x and y in the formula, but we do have t rather than y, and we do have h rather than, we have t rather than x, we have h rather than y. So our independent variable is t, or time, and our dependent variable is h for height. All right, we're being asked to find the maximum height and how long does it take to reach the maximum height. So basically, this is a parabolic function, a quadratic function that we need to find the vertex. If we find the vertex of it, then we can answer these questions. So let's take the same steps we were doing before. Now we've got to be a little careful. Notice I flipped the quadratic term and the linear term. I have the 5t squared as the second term. So you got to be careful when you're finding a, because I may put it in a different order. All right, so that's -5, b is 50. We don't have a c term, so that just means it's 0. Our constant is 0. And now we can plug it in to find the x coordinate, which will be the time, right? This will give us the time that it reaches maximum height. So we put in those values and we get a +5. So 5 seconds into its flight, it will reach its maximum height. Now, what is that maximum height? Well, we're going to put in 5 for t and then do the math. So here you want to grab a calculator, right? We're going to have some bigger numbers. So we get 250 minus 5 times 1, or 25, gives us 250 minus 125, and we get 125 meters. So 5 seconds after we launch the rocket, it would reach a maximum height of 125 meters. Okay. All right, so there's an example of kind of a modeling problem. There will be a couple of these on the assignment for today. So we know how to graph a quadratic function using its properties of axis of symmetry, vertex, and the y-intercept. And then once we know where the vertex is, we can determine whether that's a minimum or maximum and find the maximum or minimum value using the y-coordinate. All right, that's it for today. There's an assignment that goes with this in Google Classroom. Go ahead and finish up your notes and start on the assignment.